As I said, I'm Christy Elam. I am the Radiation Safety Officer for the Spallation Neutron Source. So my responsibilities are going to be here, and we're here to make sure you guys work in a safe environment. We're working with radiological materials. Sorry, I've got to get on my paperwork here and ready to go. So welcome to the Spallation Neutron Source. This training is specifically for you guys. What we're here to do is give you guys what you need to know to work as a user, as a user of Radioactive Materials here at SNS and at HIFER. So while you're here, you may be exposed to or be around radiological materials. Excuse me. You may encounter elevated radiation levels at HIFER and SNS. So this training is by law, by 10 CFR 835. These are the regulations we are under according to the Department of Energy. And failure to follow instructions when it comes to this training is going to violate that law. So we need you guys to pay attention and know what you can and can't do as a user. So requirements for qualification as a radiological worker are viewing this lecture, making sure you understand what we're going to tell you here, then passing an exam, which you guys have already done online in your pre-training, and then doing a performance demonstration. Once we finish this lecture, we'll divide you up into groups, and we're going to go to some smaller rooms, and you're going to do what we call practical factors, and we'll demonstrate use of some radiological instruments. So basically here, and clicks faster, I think. Here at SNS and at HIFER, what you're going to encounter is gamma and neutron exposures. We are, of course, neutron sources. We expect you guys to keep your exposure as low as reasonably possible. So keeping your dose as low as reasonably achievable, which is OLARA, is basically it's a regulation and requirement that we work to keep all employees or all even non-radiological workers low exposure. So what we want you to do as an employee working here is to work to minimize your exposure to radiation by decreasing the amount of time you are working in and around radiological materials and increase your distance from those. So if you don't have to be in an area that has radiological sources or reactive materials, don't. If you don't need to stand up next to something, you can step back. Make sure there's as much distance between you and the source as possible. And then also maximize shielding. So we have enclosures, we have shield walls in places. If you can stand back behind those whenever you can, that'll work to reduce your exposure. So it's expected, excuse me, that your radiation dose at ORNL will be very low. We do not expect to give you any very little exposure. It'll be less than what it'd be taking a flight across the country. So you'll very low exposures while you're here. So we do have radiological postings all in around HIFER and SNS. You are authorized to enter certain locations. We're going to tell you exactly where you're authorized to enter and where you cannot. Read all inserts on these postings before entering. It's very important. Postings can change throughout the week. Something can happen and we can upgrade a beamline to a different level. So make sure you read them each time you enter. Don't just assume it hasn't changed. You are not authorized to enter high radiation areas. So if posting says high radiation area on it, contamination area, or a buffer area that requires a frisk upon exit. That means that you need to do a self-survey yourself. Those areas you will not be authorized from this training to enter without under escort. If you have to go in, you must get an escort that is a radiologically trained worker here at SNS or HIFER. So you will wear blue TLDs they should be assigned to you. Some have gotten them already. The rest will get it after this training. We'll assign you dosimeters and you will wear those anytime you go into these areas. Look for this symbol, this magenta and trefoil symbol. This means it's a radiologically posted area. So we have controlled areas. Control areas access is controlled because of possible radiation exposure in that area. You may see standalone signs, look just like this, that say controlled area, or you may see a sign that has 5 slits at the bottom that actually has controlled area on the bottom of it. And HIFER's where you'll see a lot of those standalones. Each posted area or boundary is also a control area. So the boundaries to those areas, if the door is posted or there's ropes, those are still the boundary to that controlled area. You cannot go under those ropes without coming into that controlled area. So wear your TLDs at all times, anytime you're in and around a controlled area. Then we have This is more similar sign you'll definitely see here at SNS. This is the radioactive materials controlled area, radioactive materials area, and what you'll notice that very bottom slide of this is it says you've got rad worker training and or rad worker training for HIFER and SNS users required for entry. That's what gives you guys authorization to go into those areas, because you're getting the training now, which is the user training for HIFER and SNS, that says you can enter these controlled areas. So, so they may contain unlabeled radioactive materials. You want to be cautious. Anything that enters a radiological area or a controlled area, at that point is assumed it could be contaminated or could contain radioactive materials. It cannot leave that area without a survey. The only thing you can take out of that area is personal stuff that you had on you. So if you've taken in samples and you decide that you're only going to run part of your samples while you're in there, all samples have to be surveyed by an RCT before they can exit that area. So don't take any equipment out of a controlled area or out of a radiological area without getting an RCT's coverage to make sure it's cleared. If you run your samples and clear them, then you can go out once you've got that clearance from the RCTs. So, and just to show you really quickly a little bit about these signs. These are the kind of signs you'll see around here quite often. When we say they've got the 5 slits, all of these can be changed. So when it may still look the same, but we may have changed one of these little slides. Each of these slides are just as important as the other one. It doesn't matter what order they're in. You have to follow all of them. So it may change from a buffer area to all of a sudden it's a contamination area. Pay attention to those and know which ones you can and can't go out of. So these are very important. And so survey items, as I said, when the RCTs have surveyed something out and they've green tagged it, it is green tagged for release without restriction. That means it's something that's released that we can send back with you. It's not completely released from restriction. It can't just easily be tossed and thrown away, but it is released to come out of that control area and to be shipped somewhere if we need to get it back to you. If it is yellow tagged or it has the radiological sticker on it, it is not released. It is going to be a radiological item. If we need to get it somewhere from you, we can work to get it shipped, but we're going to have to do that. It's not something you can take and take home with you. It has to be cleared through us, and we have to take care of that. So we'll work with you on those. Leave them inside the areas if they are tagged and labeled. So, controlled area, radiological buffer area sticker sign here. This one may have radiation levels for anywhere from 2 to 5 millirem per hour in that area. So just be aware there's going to be some higher elevated levels. It's not just a normal controlled area. No RWP is required. RWP is a radiation work permit. Some of you going to HIFER, you will have to work under RWPs while you're at HIFER, and we'll work to get you on those. We'll talk about the RWPs in a moment. Rad worker training is required, of course, and you'll notice here, it will cover you for HIFER and SNS users. Some buffer areas, though, will say frisk upon exit. If they do not enter those areas, you guys are not authorized to enter the frisk upon exit. Means there could be some contamination. So, radiation area. The radiation area may have levels 5 to 100 millirem per hour. Radiation, this is up to 30 centimeters away, it is basically requires a rad worker permit. So you'll see here, it'll always tell you that an RWP is required. If an RWP is required, you got to make sure you have signed on to that RWP, and you will wear another direct reading dosimeter we call them an EPD while you're in there. So TLD and electronic dosimetry is required. It is a legal requirement that you have to sign on to that RWP. Legal as in it is covered in 10 CFR, so we have to ensure you have to do that. Do not enter an RWP area without signing in. You will enter those at HIFER. If you go to HIFER, you will go into RWP required areas. Here at SNS, you should not go into any of those areas. So in HIFER, there are proximity alarms that will sound if you get near high radiation areas. If you hear the proximity alarm, back off, get out of that area. If you stay in there and continue to set it off, you can shut down, beam into that area. So stay away. If you start hearing alarms going off, step back out of the proximity alarm. You can actually get close to the beams there. So the work permit for HIFER. HIFER radiological work permit looks like this. I know you can't read that really closely. You're going to get a closer look at it as you guys get through more training. But the RWP number is 22353. What's important on these RWPs is if it's expired or not. Of course, the effective expiration's up at the top. This thing's not very bright. The locations, what effective locations does it include? This one's the beam room and the cold guide hall. And description of work, this will determine what you can do. It's basically anybody working under the user program. This will be what you guys are specifically here for to do your experiments. And work document, this is the RSS for specific instruments, basically tells what work documents you guys will be working under. Radiological conditions, these are important. You want to make sure you understand what the radiological conditions are in that area, how high the exposure can be, and what locations. It will be fairly specific for you. It also references to surveys, and I'll show you what the survey looks like in a moment. The limiting conditions, removable contamination. If you were to get any removable contamination in the area, you're going to leave that area. And if your EPD is to go off 100 millirem per hour, if your EPD is to alarm, you are to get out of the area, contact an RCT immediately. So you want to make sure you take the right steps in that case. So you're required to have training. You're getting rad worker training for HIFR and SNS right now. So we're going to take care of that for you. And the dosimetry settings, we do set those EPDs to alarm at 60 millirem per hour and 10 millirem. So they will alarm and let you know. If they alarm, that's when you stop work, step out, contact your RCTs. So, and it does give you the requirements of what the PPE is that's necessary. There isn't any in these areas. You guys are going to be okay going into them. It also covers what if RCT coverage is required. And not required, but if the alarms go off, you do contact them and they will be there to help you out. So these are this is the RWP, and current survey maps are always posted with the RWPs. And this is what a current survey map would look like. This is similar to what you'll see at HIFR. So when you're going to sign on the RWP, you'll have the RWP to review, and you'll have a survey map with it. Review the survey map. It's going to let you know what the area looks like. So the circles you see on here, those are going to be what your actual dose rates are in those areas in MR per hour or millirem per hour. And then you'll see the large swipes are going to be. Actually, no, I'm wrong. The circles are the smears. So all those numbers are the long curlies, and the circles are the wipes where we've taken contamination wipes. The next page on here will tell you what those contamination levels were. Should be no contamination in the areas you're going to be working in, but the numbers you'll see individually here are going to be the dose rates in those areas you'll be. So if you're going to be at a desk, it'll tell you an idea what exposure rates we see in that area. So review these surveys, and you'll get a good idea of what you're going to be working in, and you can keep yourself. Work to keep your exposure low. I've been in this field for a while, and my personal opinion is you're not going to be able to work to keep your exposures low if you don't know what your exposure risk is. So familiarize yourself with the maps, make sure you understand where you're working so you can control your dose. So the electronic RWP system. So when you sign in on the electronic system, you're signing in with that electronic badge. This is going to be the EPDs. You're going to use it. It's going to be a computer screen. You're going to type into it. You'll see this. It's a computer touch program. As you put it down, you'll type in your badge number to log in. It will give you information. As soon as you put that electronic pocket dosimeter under the reader, it's going to say, give me your badge number. Type in your badge number. So whatever is directly off of, I'll stick mine in my pocket. On your green badge, there's a number at the bottom. Type in your badge number, hit enter. Then it's going to ask you for the RWP number. At HIFR, you'll put in the 22353. And hit enter, and then wait. It's going to authorize it. It's going to tell you you're authorized to go in and clear it. Once it tells you you're ready to go, you're going to remove that EPD and you're going to place it onto your badge. It needs to be next to your blue TLD. So keep them together, but the dosimeters must be worn between the neck and the waist. You can't wear them on your belt and in your pocket. They got to be up here. So I'll quit banging on that. For logging out, take that TLD, that EPD, stick it back under the reader. It will ask for your badge number. Put your badge number again, wait for a response. When it's done, it will tell you what your total exposure was, and to remove the badge and you place it back in the holder. So it'll give you exactly what you got on that electronic dosimeter while you were in there. So the first time you use this system, we're going to have guys that'll help you out at HIFR on how to use it and make sure you guys understand how to log into it. And then after that, you guys should be good. And how to wear your dosimeters. This is one of our RCTs showing you an example of your blue TLDs will hook onto your badges that you currently have as a visitor, and you can clip that EPD just above it. So we want to see anybody with EPDs clipped on their belt or have their badges down their belt. They need to be kept right up here on the chest area so we can see them. Sorry. That one makes me sicker every time. Oh, and just to give you awareness, the blue TLD, that is going to be your gamma and beta monitor. We do have another TLD type as a neutron detector, and it's the black ones. You will see some individuals, they do wear those down around their waist. The black TLDs are for neutron only. You guys aren't here for a long enough time and won't be in areas that it's concerned, so won't be assigned the black dosimeters. You may see them on some individuals. HIFR is the only place that we do have some employees that wear them. You won't see them here at SNS. So just to give you if you see one, wonder why someone has a black one, it is for neutron detection. You guys, and where you're working in the areas, you won't be at a risk of needing this dosimeter, so everything should be good. Okay, dosimetry information and rights. Excuse me. You will complete ORNL's Form 69 to receive your TLD. When we break you off into groups after this training, we have one for each of you. They actually are partially filled out for you. You just have to finish some personal information. So your name and badge number aren't filled in. You need to please add your social security number and your date of birth. Your address is for dosimetry report only, so where you want your report to go to. It's probably best if you have a home address to send it to, rather than a university or an office that you might not be at. So make sure you put in an address that it will get to you. Year-to-date question. There's a question that's asking you what is your estimated year-to-date exposure. If you have been at a facility this year and you have been monitored for radiation and you have an idea of what exposure you've received, we need this filled out. If you haven't, just note that you have not been monitored. There'll be a box for that. And 0 is a reasonable entry. If you don't think you've received any exposure, put in 0. So work history is not necessary unless you've had significant radiation exposure. If any of you guys have worked somewhere for several years and received a significant exposure. If not, just leave that one blank. And unless you work directly for DOE, answer is no to the question on special reporting. There is a question that asks about special reporting. If you guys aren't working with DOE, just mark that one as no. Sign-in date at the bottom. And you do have a right to a dose report upon request. If you leave here, we don't get a dose report to you, you have the right to request from us at any time. We will get you a report. Contact RCT if you have questions about your dose, or if you are to declare your pregnancy. Declaration of pregnancy for the females in here is completely voluntary. You do not have to declare, but if you feel the need and you want to declare a pregnancy, to make sure we monitor for that and we keep your exposures as low as possible, and you perfectly have a right to. We're going to keep you guys well below any limit for declaration of pregnancy for the time period you're going to be here anyways, but it isn't something we're required to give you the information on, so you do have a right to declare that pregnancy. A declared worker with the declaration of pregnancy is held to, it's like 1/10 of the normal annual limits. Normal members of the public we hold to even significantly less than that, so that's about 500 milligram. We hold members of the public to 100 milligram per year. You guys are going to be well below that, so I'm not really concerned in that area for anybody here. You will likely receive no measurable dose at ORNL. So, as I said, anybody has a risk of or wants to declare anything, you perfectly have a right to, but do not have to. So, in case of an abnormal condition, so examples, if there is a chemical or liquid spill or an identified spill at a beam line, you need to make sure that you are suspending work, warning others, and exiting that area. If a radiation area monitor alarms, get out of that area. If a continuous air monitor alarms, make sure you remove yourself from that area. Oxygen deficiency alarm or change of conditions, i.e. lights go out, power goes down, something happens, make sure you're working to get out of the area. Or if you lose your dosimeters, you notice that you don't have a TLD on anymore, your EPD fell off, exit the area, warn others, let them know what's going on, and make sure you notify your sponsor, RCT or facility management. Or if you've got a beamline scientist there, make sure you're notifying someone immediately in these conditions. So, follow safety instructions and postings. You will get more detailed safety instructions from the beamlines as you work with them. The scientists will work with you. And then, of course, use common sense. Everybody here has a brain. Ask for an escort if you want to enter an area that you are not allowed to enter. And we'll make sure the escort works with you. And use your resources. Instrument scientists will be with you. They are there to help you. Ask them questions. Let them work with you. Contact your RCT if you have any radiological questions or concerns. RCT numbers are posted all over the facilities. You'll have signs everywhere. Contact them. They also have a hutch. When you guys do a tour, they'll show you where their hutch is, where you can find the RCTs. We always have someone here at any time of the day. So, and the IHTs and controller and operators are on duty 24/7. Those guys are also reachable at any point in time and can help you out. So they'll get you whatever you need. So, working safely with the instruments, the radiated samples must remain in the radioactive materials areas. You cannot take them out. They have to be surveyed by an RCT before they can leave. So if you pull your sample, you've taken a quick survey with the instrument, and it doesn't alarm the instrument, you can store it in the radiological cabinet there that's for it, but you cannot take it out of that area. You cannot manipulate samples. Do not open them. Do not do anything with them once they have come off beam. They cannot be manipulated. We have to have approved workers to handle and work with those. So make sure that you are controlling those. And do not open them. If one breaks, you contact RCTs immediately and let the instrument scientists know right away something's happened and step out of that area. Check radiation levels as you change samples. As I said, if you alarm the instrument, you're going to check with a little RAD-IG instrument, and the limit on it is 2 millirem per hour. If it alarms, back off, contact RCT. They'll come out and survey it for you. So if it doesn't, then you can store it properly. So the practical factors demonstration, this is what we're going to do immediately after this presentation. You complete this training, you're going to demonstrate how to perform a proper sample screening. So we're going to have instruments, they're called the RAD-IGs. We're going to have one for you to actually use and show us that you guys can actually use them and give you an example of what the alarms sound like. So you'll hear the alarms go off and you'll know what different alarms we have on them. So on completion of this training, you will be authorized to screen a sample after neutron exposure with that portable instrument. So you're going to turn the instrument on. You're always going to check the background before you get to your sample that you're going to survey. So stand back, turn it on, make sure you get a stable reading. Background should be anywhere from 5 to 15 millirem per hour. If the meter does not indicate a normal background, call your RCT and do not use that instrument. Place the probe, though, close to that sample. On the back of those probes, you're going to see it here shortly, there's a little plus sign, and you're going to make sure you line that plus sign up with the sample you're surveying, and that's what you're going to look for. Hold it steady. Wait till the reading settles down so you actually get a good reading on it. If it alarms, as I said, just back off and give that call to the RCTs. And then when you're done, please ensure you turn these instruments off. We will go through how to do that. They run on a little battery, and batteries can be costly after a while. We'd like to save them as much as possible. So turn them off when they're not in use, and then you turn them back on when you need to use them. So remember to scan detector over sample slowly with about a within about a half inch of the surface. You don't want to lay it on the sample, but get about a half inch away, and move at a very slow rate. So just holding it up and go, whoop, it's all good. That's not going to work. You're going to have to go at a good slow rate and get a good number on it. So, and contact your RCTs if that meter goes off. Yes?
You just said that background should be 5 to 15 milligram per hour.
Oh, sorry. Microgram. Sorry, that's my fault. Yes, it is microgram, not millirem. And that's another thing about these, you should remind me another thing about these instruments. They're digital readout, and they automatically do shift on the units. So you'll have to look, it'll have a U for micro, and it'll flip to an M, so pay attention to which one it's, I mean, if it goes over 2 millirem, it'll alarm, but you'll pay attention to which one you're reading on that. It does flip automatically. It doesn't tell you it's flipping, so that's sorry, my bad on that one. Following this talk, you're going to be directed into the breakout session. We're going to give you your dosimetry right away, and we will go through the practical factors, and you guys will be trained as users at that point. So feel free to ask questions. You guys will have either an RCT with you or one of the RPOs, so we'll be able to answer any questions you have. And before working on experiments at HIFER and SNS, those instrument scientists are going to give you a brief kind of safety at the beam lines. Each time you go to a new beam line, they should be giving you some instructions on what to do. So another opportunity, you got those questions, ask them, and they'll take care of it for you. So we hope that your work is productive and you guys have a good time and learn a lot while you're here. It's a really interesting place. So last one I want, because I want to see how many pay attention. What do you do if something goes wrong and it's radiological? Call your RCTs. Thank you. Very good.